Good afternoon, and welcome to today's webinar, Tecnomatix Plant Simulation and How to Optimize Your Production. So I'll run through the agenda, and I'll introduce myself. My name is Glenn Borgesen. I'm an application engineer here at Geometric Solutions, and we'll talk about who we are in the beginning here. Then I'll get into Tecnomatix Plant Simulation and what it is, how it can help you, and how it can help you optimize your production and throughput. And then we'll look at some case studies, and then I'll get in and show you a brief demo of a typical scenario that we'll run through in plant simulation. So Geometric Solutions is the company I work for. But before we get into this, I want to talk about the any questions that you'll have. If you want to ask a question, please go ahead and type it in the flyout. And then later, after this webinar, for the attendees, we'll be sending you information to look at some of the information that we presented today. Now, I'm part of Geometric Solutions, as part of the broader Weltonen family of companies. And we have Weltonen Engineering, where we use the best-in-class software, which is Siemens Solutions. And at Weltonen Engineering, they have hundreds of engineers and designers that use Siemens software, and they can design anything. And then we have Independence Tooling Solutions, which can build anything that they design. So you can see we've kind of got you covered from beginning to end using the software that we're selling. And our president, Lloyd Brown, said, "Our ability to successfully partner with our customers comes from our experience in using the tools we sell every day." So he's really putting his money where his mouth is, if you want to say that. He is definitely doing that, and that's exactly what we're doing here at Geometric Solutions. So let's talk about plant simulation. What is it? How can it help me? How can it help you? And what are the benefits of having it? So today's industries, you have all kinds of issues, and plant simulation helps you detect, eliminate these problems that would otherwise require costly and time-consuming correctional measures during production ramp-up. And this is not the time that you want to be making those changes. So you can use plant simulation to minimize that investment. So when you look at compressed timelines that increase quality, lower cost, and then on the manufacturing side, validation, process, cost overruns, all these events can help or will increase your risk. Plant simulation can help reduce those by building virtual models and testing out your ideas before you even start. So how can you mitigate your risk? You can use plant simulation to help you get rid of that physical problem. I want to be making my changes virtually with plant simulation, and I want to go into my plant and build that physical model and complete that digital twin. So plant simulation will help you get there. Now, what is plant simulation? Well, it's a discrete event simulation tool for the modeling, simulation, analysis, visualization, and optimization of production and logistics. That's a mouthful, isn't it? Well, think about it like this. Plant simulation is a virtual place to explore your options, build your next line or assembly plant, all while reducing errors that in the physical world would cost a huge amount of money. So you can do this planning and testing virtually. And what will plant simulation help you to do? It's going to help you detect and eliminate problems that would otherwise require costly, time-consuming measures, and you'll be in ramp-up doing it. And that's, again, not when you want to do it. It'll also help you minimize investment costs for the production lines without jeopardizing required output. So you can work, again, virtually. And then it'll help you optimize the performance of existing production systems. So you can use it to develop them and improve a physical system. So there's a lot to be said for how it can help you. So what are the benefits? Why use this? Well, it'll help you reduce your investment in planning of new facilities. It'll help you increase your production and productivity. It'll reduce inventory. And now, if you're in the plant and you're told you can reduce your inventory, well, that's a huge, huge benefit. And it'll increase your throughput. So there's two things that the plant folks would love to have. It'll help you optimize your system dimension, including buffer sizes. And we'll look at that in our example today. It lowers your investment risk. So you have an early proof of concept. You got a blank whiteboard to work on, and it's just going to cost your time and efforts. But you've not built anything. You can find out all the pitfalls. It'll help you minimize and utilize and maximize the utilization of your manufacturing resources. It'll also detect and eliminate problems digitally instead of physically. And again, that's the big thrust here, is that it's going to help you on the virtual side. So let's look at some case studies. And these are real world success stories. So Siemens asked about 600 plant simulation users in a couple hundred companies to estimate the cost value ratio based on their experience. And they came up with a cost value ratio of 1 to 12. Well, it's huge. That's fantastic. And so the average return on investment is about 8 months. So when you think about the cost of the software, if I'm getting my money back in 8 months, it's almost kind of a no-brainer. It really is. It's not really free, but the payoff is very, very, very quick. So WP Performance System doubled daily output. They reduced their overtime costs by 85%. They had a 23% reduction in net processing time and a 60% reduction in work in progress in process. Now those are big numbers, but that's what plant simulation can do. Another case, Electrolux saved $2 million in buffer space in related investments. And then a German car company saved 3 million kilowatt hours of energy using plant simulation. So there's a lot of benefits to using plant simulation, and it can help you out quite a bit. So what I want to do now is talk about a typical situation. So we're going to do a live demo on a kind of a typical situation that we run into here at Geometric Solutions. So we're going to use diagnostic tools to optimize our performance and increase our production. So typically, we'll get a call from a customer, and they'll talk to us. We'll get some information, and we'll start building a simulation model to demonstrate for them and test out their ideas and just show them what it can do. And once we know we're ready to have the model optimized, we can get back with the customer and show them what we can deliver them. Now, in real life, you'll start a project, you'll start working on it, and then there's some change that comes up. So we've incorporated a change in this demo, and there's a 3-station line, and on the 3rd station, we've added an operation. And we want to still maintain the optimum throughput and efficiency. So we go through and we create a new model to get a proof of concept, and we have a pretty good idea that we're going to show the customer, how this tool can help them out. And we take the next step, and what we're going to do is explain how we got there. So we use diagnostic tools. We ran experiments. That's a diagnostic tool that you can use in plant simulation to kind of test out your ideas, so you don't have to take too many educated guesses. You can just kind of make an educated guess to what would be optimal. And we're able to build a couple different variations of the line. And so I want to show you what we came up with here. So again, I have my plant simulation model here. And again, I built a very basic line just to get this point across. But again, we have 3 stations, station 1, 2, and 3. And we put information into the system as much as we have so we can get better results. So I have a source where parts come in to station 1 and move on down to the line, and then there's a shipping. So we'll develop those later in the next few webinars. But what I want to do is talk about some of the information that we put in this. Now, in the stations, all 3 of these stations, I set the processing time to be 36 seconds so that at the end of an hour, we have 100 parts in the ideal world. And speaking of the ideal world, what we can do is inside the stations is we can set up failures. And what this is a way to look at your production and build in the availability of your machines. Now, in this case, I'm going to use 80% of the machine time we'll be running. And this is information that you can get right from your plant. Like you've got machines working out there, you know pretty much how much they run. You can build that right into your simulation tool so you get a really good results. And we'll use 1 minute for mean time to repair. Now, I did this in all 3 stations. So they're all at 36 seconds and they all are running at 80%. And then in between the stations, I put buffers just to keep things running. And in the buffer, right out of the gate, just placing that buffer in there comes with a capacity of 8. Whether or not I need that remains to be seen, but they're at 8 right now. So what I did was I built a simulation, and I set this simulation to run for 10 days. So I'm going to run 10 days of simulation with just my regular simulation tool. And I'm going to monitor my station. All 3 of my stations will be monitored. And I'm going to monitor the buffer capacity. These are some analysis tools that let me look at what's happening in my simulation tool. So I'll go ahead and run 10 days of production. And this should take just a couple seconds. We're done. We're done. That quick. That was 10 days of simulation. And I have a throughput of almost 75. So 74.95 is my production rate right now. Now, I haven't done any optimization. I've just kind of set up my tool and started building it. So what I want to do next is look at a little bit more of this. Now, I've got these resource statistics that give me an analysis of what my 10 days of production look like. I'll make this a little bigger for everybody. Now, the red part up here at the top is failed. That's the 20% failure rate that we built into our tool so that we can get a really accurate facsimile of the simulation. The green is working. So I see my green is right about 75%, but I see this yellow and the gray, and I see that that's waiting and blocked. Now that is an inefficiency that I can deal with. Now it's a few percentage, but over a year and thousands of parts, you can imagine the cost will ring up. So I want to get this model optimized. And what I can do with that is I can use this tool called an experiment manager. So I'll show you basically how I set up my experiments to run, and we can look at what that gives you. I'm not going to go through all the details of this, but I want to show you the experiments that we can run. So when I show you this experiment dialog, you'll see that there's 15 different experiments, and I've named them buffer capacity. I gave them 2 through 30. And then these are going to be the buffer capacity sizes that I'm going to run all these experiments with. So I'm going to run 15 experiments, and I'm going to run an observation of 2 for each. I'm going to run 30 different productions in just a few seconds. And this is 10 days for each observation. So I'm going to go ahead and run this. You'll notice it'll take a little bit longer to run that. But again, I just ran this experiment in just a little over 5 seconds. That doesn't matter. It's just showing you how fast it can run. And then I want to show you this report that I get. Okay, now we can tailor these reports too to display information as you need it. But what I want to do is show you, so the overview, these are all the different buffer capacities that I set up in my experiment, if you recall. And so the simulation effort was 15 experiments with 30 simulation runs. And I did that in just a little over 5 seconds. And you can see the throughput is increasing as we go down. So the buffer capacity gets larger, throughput increases. You really want to kind of nail down, like, what is the optimum capacity? And if I go down and look at this graph, what's nice about this is visualization really helps me. So I can see that somewhere in this area where the curve is starting to flatten out, I'm kind of reaching my sweet spot. So a buffer capacity of, say, 16 might give me an optimal production. And that would be comparing the value of a 16 capacity buffer as compared to a 30 capacity buffer. Does that outweigh my production cost? So this is something to consider. So anyways, I know that 16 would be a good size for my buffers. So let me reset my simulation, and I'm going to go into my buffer, and you're going to see that the value of 30 is there. Now, I started with 8. What happens is, when I run my experiment and define my experiment, the buffer capacity with 30 in the beginning here, that creates the most parts, but that might not necessarily be what's good for me. So I just want to show you how we got to that. And what I'm going to do is I'm going to take my capacity and put in 16. And I'm going to rerun a simulation. And remember, we're shooting for 74.95. And I did increase my production a little bit. I'm close to that 80%. Okay, so I did optimize that. And I can look at an HTML report. What's nice about this is it breaks down the information that you get in a nice organized way. And you can set this up so that it's very clear. So when you send this out to any managers or any of the bosses that are going to spend the money to do what you're telling them to do, you can show them this report. And it breaks it down so I can see my 2 stations or 3 stations are all about 77%. I've got a couple percent of weighting in block, but I've kind of optimized that with my buffer sizes. And then all these charts will be here, so you can, so when I look at the resource statistics, I can see, well, the exact numbers. If I need to see them, I can come and look at the detailed report. But now remember, when I was talking about this, we had a situation where there was a change. So I built this simulation model, and then the customer calls up and says, oh yeah, in station 3, we need to add an operation. Okay, no problem. We haven't built anything but a simulation tool. It's all virtual right now. So what we did was, in the same file, is I created a new simulation, and I split the stations. This is just a guess right now, but I figured, well, I've added 18 seconds of time to each one of these. if I double those, I can still probably reach my production. And again, my buffers here are at 8. Both of them are at 8. And my cycle time on my last 2 stations is 54 seconds instead of the 36. So I've added another 18 seconds to these two on their station time. Excuse me. So I'll, again, run my simulation of 10 days, right? I'm going to run my simulation and see where I'm at, find out how close I am to that 80 parts per hour. And I'm going to find out that I'm a little bit short. So I need some help here. And if I look at my station utilization, again, I see the yellow and the gray. Now, the gray here in station 3 and 4, I'm probably going to have to live with a little bit unless I want to add more equipment, but we'll decide that in the later date. But I really want to optimize station 1 and 2 and see if I can get a few more parts per hour by changing some of the buffer sizes. So in this experiment, what I did was, again, I ran 10 experiments and I changed the buffer capacities from 1 to 100, and I changed some of the values there just to see which way I need to go with this to build the optimal production. So again, we'll go ahead and run production on this. Should take 5, 6, 7 seconds to run all this. Well, 3.5. That's not so bad. I don't even have time to get a coffee. So I look at my experiments. I've got all the different experiments with the buffer capacities, and then I can see the throughput here. Well, right away I can see the buffer capacity of 100 is going to get me the most throughput. But again, I have to weigh the values. So maybe a buffer capacity of 15 will offset the cost of a capacity of 100. It's something I'll have to go back and look at. So I'm almost at 80 parts per hour, which is really excellent with that. But my buffer capacity is at 100. So again, if you remember, in this experiment, the graph here that I really want to focus on when determining this, sorry, that's the wrong graph, is this graph. So right in the flat part, I'll go with buffer capacity of 15 and see what that does for me. So again, it'll put it at 100 because that was the highest rate of production that I could get with that the experiment built right in. So I'll go back to 15 and I'll run a simulation, make sure I reset it, run my production, and I'm up to 77.7. So we took a little bit of a hit, but I have the situation here with this line, and it's just going to be something that I'll have to deal with now. What we'll do in the future is we'll add some more equipment, maybe a robot, a couple of humans, we'll add a calendar, and we'll still continue optimizing production and throughput in the tool. And what I want to show you is that this plant simulation will let you do what's called a pack and go. And what this does is it will create a file, and I'm just going to put this on my desktop for now. And I can send this out, and again, with everybody that's attended, we'll get this to you in an email, but basically what this does is allows somebody without plant simulation to launch this executable and run this exact simulation that I have right now. So we'll suspend disbelief and say that we've sent that out to everyone. And so what we've seen here is that we used diagnostic tools and ran experiments, right? I had my station utilization, buffer capacity charts out there, I had HTML report, and we can get some money saving. I can increase throughput. I haven't done anything physically yet. This is pretty easy to use. The features are pretty straightforward to build. We got a smooth running production, high utilization, pretty rapid decisions. And this is what geometric solutions can bring to you using plant simulation. So this wraps up today's webinar. I'd like to thank you for attending. For more information, you can reach us at solutions@geoplm.net or scan the QR code for more. And if there's any questions, we can field those now. If not, I'd like to thank you for your attendance today. And I'm looking for questions. I don't see any questions right now. So if you have any questions, go ahead and email them to us. Again, that's solutions@geoplm.net. Thank you for attending today. Take care. Bye.